In this video, we're going to take another giant step toward power-ups by adding coins and gems that spawn when the bricks are broken. This is going to be very similar to the lasers we added in the last video. The key difference is that the coins and gems will be moving down when a brick is smashed, rather than up when a key is pressed. To do this, we'll need a sprite class for the following objects. We'll need a group to manage them. We'll need to add to the ball brick collision code to generate them, and we'll need to add collision code so the paddle can catch them. Let's start by creating a droppable sprite. I've downloaded coin and gem images from pygame..Org and a couple of sounds from freesound.org. I've linked them in the description. I'd like to create a sprite class called Droppable with a coin or gem image that drops from an XY location to the bottom of the screen and that can play a sound. The droppable needs to know what it looks like, what sound it plays, and how fast it falls. To exercise your pygame muscles, pause the video and create Droppable. How do you do? Here's mine, a subclass of pygame.Sprite called Droppable that takes an image, sound, XY coordinates, and speed as parameters to init. Unlike the laser, the droppable needs to know where the bottom of the screen is so it can remove itself from all groups once it falls off screen. The update method, therefore, takes the screen as a parameter. Now we need somewhere to store the droppables, so I'll create a sprite group for them. Then I'll clear, update, and draw that group in the game loop, just like the others. We'll spawn droppables when bricks break, maybe around 20% of the time, and we'll check for collisions with the paddle and play the droppable sound upon collision. See if you can add that to the game and come back. The only part we haven't done before is generate sprites only 20% of the time. We can use the random library, but don't get stuck on that. I'll show you how when you come back. How do you do? Here's my solution. In the asset setup area of the game, I have an empty group called Droppable Group. I also load in the images and sounds. I've put the images in a folder called Images to keep my game folder organized. In the game loop, I completed the homework from the last video and updated all collision code to use Group Collide. That code is available in my GitHub repo called Brickout 6.0_homework.py if you want to check it out or work from it yourself. If there are collisions between the ball and any bricks, we already iterate through the collided bricks with forBrick in BrickHit. To spawn a droppable for 20% of the smashed bricks, I've written if random.random is less than 0.2, droppablegroup.add, droppable, coin surface, coin sound, brick.rect.center x, brick.rect.center y, which creates a coin at the center of the smashed brick. We could randomize both the image and sound with random.choice, and randomize the speed with random.randint if we want to generate both coins and gems with random speeds. To hook the droppables into the game, I send the droppable group the clear message with the other groups, and update and draw down at the bottom of the game loop with most of the other groups. To catch droppables with the paddle, I check for collisions between the paddle and the droppables, removing droppables from the droppable group upon collision, and I send the caught droppables the play sound message. Let's run it. We get some random coins and gems falling from the bricks at varying speeds. When we catch them with the paddle, they play a sound and disappear. Now, this works fine with 2 droppables, but what happens when we eventually have 10 or 15 different power-ups? The more we add, the more complex our code will get, especially if we want to allow complicated layered effects that work for a limited time when a droppable is caught. Complicated code is more difficult to debug and extend, but if we encapsulate our new functionality into objects organized with an appropriate design pattern, we can make the code much easier to extend, maintain, and understand. I'm going to show you a pattern right now called a factory pattern that will keep the game loop code consistent, but will allow for a variety of future droppables, even ones we haven't thought of yet. So we will refactor what we have to make our droppables more robust and extensible. And to show off the extensibility of the refactored code, we'll add a new kind of droppable with only a few lines of code that will work with the structure we put in place. Here's how that's going to look. I'm going to still have a droppable sprite, but I'm going to have a class that manages the creation of droppables, and this will make it easy for us to have many different kinds of droppables with different sounds and appearances and anything else we want to vary. I'm going to call this droppable managing class Droppable Factory. A factory is an object or method that creates other objects. We make this extensible, easy to add new droppables, by separating the data from the methods. If we put all the information that we need to create a single droppable into a dictionary keyed on droppable type, then we can write a method that will create and return any droppable when given the type. Let's build that dictionary. For each droppable, I'm going to have 3 entries: callable, image, and sound. The image and sound are easy. That will be either the coin or gem image, and I have 2 different sounds for those. But what's callable? This is going to be the class name, so droppable. A method or function name is something we can store in a variable and then invoke by putting parentheses after the variable. I'm assigning the class name to my dictionary key callable, so I'll be able to call it when it's time to create the droppable by putting parentheses after it and placing the initializer arguments in the parentheses. Remember, that's how we create an object. Right now, both of our droppables are of the droppable class, but we could put any function here that constructs a sprite. So in my outer dictionary, I have the strings coin and gem. And in the inner dictionary for each, I'll have callable as the key and droppable as the value, and image as the key, and then the appropriate image as the value, and sound as the key, and then the appropriate sound as the value. Right now, we randomly generate a droppable down in the game loop. I think we might eventually want to associate a droppable with a specific brick, and maybe spread those out over the bricks semi-evenly so they don't clump, but we're not going to do that in this video. We'll just keep it random upon collision. I'm going to put methods in place to facilitate that future upgrade, though. The first method is getRandomDroppableType, and this will return a key from our outer dictionary, a string representing a droppable type. Right now that's coin and gem, but as we extend the dictionary, it will draw from all of the available types. I'll randomly select from the keys in the dictionary. The other is going to do the work of creating a droppable, so I'll call that drop, and it will take the droppable type string, and it will take X and Y coordinates. Those come from the smashed brick. And we'll return an instance of droppable or none if somehow we get a string that isn't a dictionary key as a parameter. That's just a little defensive programming. Now, this code works with the dictionary data structure. I'm going to first pull the dictionary value associated with the droppable type and call it attributes. Attributes is the dictionary for that specific type of droppable and includes callable, image, and sound. We'll invoke the callable by putting parentheses after its name and passing in the other values as arguments. The droppable initializer takes the image, sound, and X and Y coordinates. The method will return what we get back from invoking the callable, which will be a droppable. Down in the asset creation area, I'll create a droppable factory. And in the game loop, rather than creating a droppable directly, I'll get a random type from the factory and then send that random type to drop and put what we get back into the droppable group. Again, in the future, we might want to evenly distribute these among the bricks, and so we won't be generating a random type here. We'll make it a field of the brick. But for now, this works just fine. I'm going to crank the percentage of droppables up to 80 so we can quickly see some droppables when we run the game. And yes, we're getting a lot of gems and coins, each with their own sound. Now, let me extend this to show you how easy it is. I could extend this to include another generic droppable with a different image and sound, but let's do one that's a little bit different, a paint droppable. This will look like a paint drop of a random color. As a power-up, this could be used to paint the paddle, balls, bricks, or add a skin to the whole game. I'm going to implement it as a subclass of droppable. The behavior is the same, but in the initializer, I'm going to randomly generate a color and color the paint drop, which is the paint droppable's image, to be the random color. I recolor the sprite dynamically using a mask. We'll explore masks more deeply in another video. Now, down in the Droppable Factory, the only thing I need to do is add another entry to the dictionary. I'll make the key paint drop and put in the image and sound, but for the callable entry, instead of that being droppable, it's paint droppable, the subclass. Remember, this is the class that's called to create the droppable. That's it. By separating the data from the code that creates the droppable, we can easily add new droppables without having to monkey with our code. Now I'll run that, and we have a mix of coins, gems, and paint drops. A lot of what we did in this video was familiar, creating sprites dynamically and checking for collisions. The newest part that might take a little practice is the factory pattern and storing a method in a variable. So to practice, I recommend you first make small changes to the dictionary to ensure the structure makes sense. Change the images and sounds. Then make another sprite of the droppable class and add it to the dictionary. Then add another sprite of the paint droppable class to the dictionary, maybe a gummy bear. It's easier than you might think. All you'll need to change is the image. Finally, if you want a challenge, subclass droppable and add another entry to the droppable dict with your new subclass. You could try creating a diagonal droppable sprite that moves diagonally, a gravity droppable sprite that accelerates as it drops, or maybe a transforming droppable that flips its image as it drops using pygame.Transform.Flip. If you get stuck or want to share your successes, please drop a comment below. And as always, have fun and keep coding.
Ho, 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 Merry Christmas! Ho, 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 Merry Christmas!